Good morning. Let's get started. Let's talk about GStreamer. What's coming up? What have we been up to? Just some updates, basically. Nothing too low level, just some high-level overview to for those who are not following every day. Quick introduction. Who am I? I'm Tim. I hack on GStreamer. I'm one of the maintainers and developers, and I'm also the release manager when we get to releases. Next, what is GStreamer? You probably know this, just to run quickly for those who are interested. It's a multimedia framework, which means audio, video, subtitles, etc. We try to be cross-platform, toolkit agnostic, so we're not tied to GNOME. We try to work with, Qt, OpenGL, whatever you desire. We try to integrate with everything, basically. We provide libraries for you to build applications on top of. And we have very high-level API and very low-level API. And we don't invent the world ourselves. We wrap other libraries and make use of them, like FMPEG for software decoders and encoders, for example. We have specific high-level APIs for specific use cases, like a play bin for media players. We've got encode bins. We've got an RTSP server API. You can put your camera or whatever you desire on the, serve it as an RTSP stream with 6 lines of code. Video editing, WebRTC, voice over IP, we can do it. And we try to integrate with everything. So if you have a problem integrating with whoever you want to use GStreamer, let us know, please. All right. What have we been up to? First of all, releases. There was supposed to be a release already in December, if not before, and it's not there yet. So next release coming up is 1.16. We try to do a 6-monthly release schedule, so as you can see, it's kind of working out. Next release coming up is 1.16. That should be out this month, hopefully. And after that, with a bit of luck, we might get back to our 6-monthly release schedule. My excuse is we've been moving to GitLab. So before we've been tracking bugs and patches in Bugzilla, and that was okay for a while, but the world has moved on and people want different workflows, and GitLab is great. So we moved to GitLab freedesktop.org. You can file your patches as merge requests there. You can file issues there, and everything has been migrated basically. And people just want that sort of GitHub merge request style workflow, and it's much nicer. And we can merge stuff with a button, which is also nice for us. Also, we get CI. Continuous integration, which basically means we now check, if the code compiles and if the tests work before we merge stuff. It's awesome, isn't it? Couple of things that landed in 1.14 and afterwards. WebRTC, that's already there. It's basically when people ask, how do I stream stuff to my browser? The answer is always, it's complicated, which browser, which platform, which operating system. You have like a five-dimensional matrix, and it's a lot of work. And then you can't really do low latency. WebRTC is a common standard. It's implemented in all the major browsers. It provides for low latency streaming, basically, and it rocks. It means you can now stream to your browser very easily. You don't have to consider 29 different codecs on 50 platforms, but it'll just work. It's really cool. People have been building really nice stuff with it. Most people use Google's WebRTC library, which works nicely if you want to build that and integrate it. But it's not very nice to use. So we have our own WebRTC stack, basically. And that means you can use it, you can stream to browsers, you can build your own applications, and any stream works. You can leverage all of GStreamer, which means you can use hardware-accelerated encoding and decoding. Everything that works in GStreamer will work with WebRTC. You don't have to encode or decode. You can just remux if you want to. So that works nicely. A couple of new features there are in Git for WebRTC. We've got data channel support, bundle support, forward error correction. That means lower latency basically, and making sure that we can correct errors. Retransmission support, which is another way to correct errors and make sure we don't miss packets. But retransmission means more latency, whereas forward error correction means higher bandwidth. In general, we have landed a forward error correction framework support in our RTP stack that can be used not only with WebRTC, but we've also used it in RTSP, and you can also use it standalone if you have use cases for that, if you just want to make your own RTP pipelines. The trade-off is basically latency versus bandwidth. Forward error correction means you can check what the connection is like, how much packet loss is there. If you detect packet loss, then you can sort of increase your bandwidth a little bit and transmit more redundancy. And that means the receiver can basically restore missing packets without having to ask and wait if they come back again. You can just restore it. We've implemented an RTSP server for one method, but not for the other. AV1 video codec support. I don't know if you've heard of AV1. AV1 is a new video codec. They've frozen Bitstream recently, and it's basically a royalty-free next generation video codec. If you like, it's basically what Opus Audio did for video. I'm really excited about that because it means, once that lands and we get support for that everywhere in hardware devices, etc., your Android phones, basically, we will be able to have a patent-free codec stack for audio and video that can be used everywhere. We've improved support in GStreamer. We added support for various containers, and we also improved the software encoder. The software encoder is still very, very slow, but it works, and we added more options for you to fiddle with. I'm sure it will improve over time. Embedded systems, loads of improvements there. I'm not going to talk about that because Olivier has a talk about that later, so go to that, and he'll tell you all about it. SRT means Secure Reliable Transport. It's basically a new protocol. It tries to sort of find a different trade-off between TCP, which gives you reliability, and UDP, which just means you send packets into the void. It's basically a replacement for RTMP, sort of broadcasty streaming use cases, and it found a lot of adoption in the industry. So we support it. We recently refactored the elements to make them more natural to use in our SRT environment, and we basically changed the way that the sources and the sinks work, and they can both work bidirectional. Playbin 3 is our sort of Playbin abstraction. We've added recently support for gapless playback and for pre-buffering. So basically, if you play audio or video or something, once the download of the old file finishes, you can immediately start downloading the new one. We had that in the old system as well, in the old Playbin. But the problem was, in the old Playbin, everything operated in raw decoded video and audio domain, which means you needed multiple decoders working at the same time. The new abstraction doesn't do that anymore. So that means if you are on an embedded system, you don't suddenly have multiple decoders running in parallel, completely, starving your very limited embedded resources. So that works quite nicely. NVIDIA Graphics has various APIs for hardware-accelerated encoding and decoding. NVDEC and NVENC. We had already an NVENC encoder to leverage that and encode stuff with hardware. We've added some new formats for the encoder, H.265, which is HEVC, and the decoder is new, so we can now decode as well. And we upped the support for new SDK versions. And all that integrates with OpenGL and hardware acceleration and stuff, so you can do zero-ish copying, etc. Some stuff that will land in the upcoming release. We have loads of optimizations everywhere, as always. Buffer list support, we got rid of lots of little allocations for all kinds of stuff. Non-interleaved audio means we have to, less copying to do in order to rearrange channels and stuff. We worked quite a bit on reducing latency in various elements, which means, you can start up quicker. Video encoder and decoder, we improved the parallelism by dropping locks when they're not required. OpenGL, UDP source can now capture packets with a buffer pool, which also means fewer allocation churn, basically. And OpenGL has DMA buff improvements, which is good for zero copy on Linux platforms. One big thing that's always been missing for years, and I've been mentioning it, and finally we have it, closed captions. Closed captions are basically these text subtitles you see on TV stuff, and it's mandatory for lots of use cases. Broadcasting people need that stuff. So we've always didn't really have proper support for it, and now we have proper infrastructure, and we have implemented it in many cases. So we can capture it from SDI signals from capture cards. We can output it. We can read it from MOV files. MPEG-TS, of course, that's what you get as digital TV basically, and also standalone files. We've got SCC and MCC support. So we can build really cool stuff. And of course, we've also got plugins. You have an extractor, you have a combiner, you have converters, and we can also extract them from old analog signals, basically. So that means that we can put basically we can put closed captions on the video buffers and pass them around in the pipeline, and you can mix them and extract them and reroute them, and they can also live as a separate stream, basically. So we can do lots of new cool stuff with that. We have a new WebKit-based source element, which means it's basically acts like a browser, so you can stream whatever a browser would output into your a pipeline and make a video stream of it. That's quite cool. RTSP server, that's our server library that you can use to make something available via RTSP. It has seen lots of improvements, performance improvement for TCP interleaved streaming. We have forward error correction support now, and soon we also have support for on-with trick modes, which is used for security cameras if you want to, review footage. And trigger modes is basically fast forward, fast reverse, etc. The Intel Media SDK is basically an API that is provided for hardware-accelerated video and audio decoding on Intel graphics hardware. And we've got plugins for that as well now. And they've got improvements for new codecs, DMA buff support, and video post-processing for decoding, which makes the video look nicer, basically. We have various plugin modules. One of them is GSD plugins bad, and people don't like the name bad, and it's not very nice, but yeah. So we have an ongoing effort basically to move things out of bad into other modules like GSD plugins good and base and whatnot. That always takes a little bit of work, but we're working on it. So the latest stuff we've moved is video aggregator, which is a base class for mixers. It takes multiple inputs and it handles live inputs properly. So if you have multiple video inputs and one of them just drops off because someone tripped over the network cable, you want the rest of the pipeline to continue, right, and not just the entire pipeline to locked up. You want to make sure that you still produce video just with all the other inputs. We can do that now. And video aggregator is basically the new base class for that. And we've moved that into GSD plugins base, which means we can also move our compositor plugin into base, which is our video mixer, our new video mixer. And there's also OpenGL-based mixers, which do the same thing, just hardware accelerated. And they're also in base now. So that's quite cool, because that's quite an important part of many GStreamer pipelines. And hopefully the next bit we move will be GSD Player, which is a new media playback abstraction. Stuff coming up in the future, maybe neural networks. Neural networks was like the hottest topic at the GStreamer conference last year. I mean, everyone's doing it. If you're interested in that, there's really cool stuff. Look at the talks page where you find all the talks recorded. Scalable streams is also a big topic. Scalable streams basically means you have some kind of base layer that you can decode individually. And then you can have extra streams, and they provide more features. For example, you could have one stream encoded in full HD resolution, and if you want to go up to 4K, you have the second stream. And instead of having a second stream that is encoded individually as 4K, you just encode the difference. The same thing, for example, for normal video, and then you want to provide high dynamic range, more colors. You can do that as an enhancement stream, for example, or higher frame rate, things like that. Yeah, these are big topics, and we're working on signaling for that in GStreamer architecture and infrastructure. And hopefully one day Playwin will just be able to pick it up and it'll just work. Trick modes. Usually when you change the speed of something, especially in things like adaptive demugs, like Dash and HLS pipelines, it takes a while until you change speed, and you have to basically flush and then seek somewhere, and then the new speed happens. It'd be much nicer if you could sort of just change without without breaking the data flow, and we can do that now. We can basically, well, not now, but that's something we work on, and that will hopefully land after 1.16 at some point. That you can much quicker switch speeds and make them faster and slower. We always do performance optimization. There's lots of stuff coming up. What else? A couple of things. Meson build system. We've been working on moving to that for a while. It's really cool. It's really fast. If you haven't checked it out yet, do that. It's basically like, keep all the nice parts of CMake, but do something from scratch. And it's widely adopted. I mean, lots of people are moving to it. GNOME is moving to it. Systemd has. I think VLC might be working on it. Yeah, Mesa, and we as well. So our goal is basically that 1.16 is hopefully the last release which will have AutoTools built, and with a bit of luck we will be able to remove it in the next cycle, and then that will be the end of it. Yeah, we can build on the Microsoft compiler using that because AutoTools didn't support that, which is nice. Rust is something, it's a new system programming language, if you haven't heard of it. It's basically like the C++ we always wanted but never got. So, yeah, fast, safe, productive, pick-free. It's really cool. People are checking it out. It's a really cool community. It's really what we need as well. The ecosystem is really nice, and it's being adopted by lots of people. I mean, Mozilla are using it widely, but also lots of other companies. We don't have, just to warn you, we don't have a plan to rewrite everything or something, but we have really good Rust bindings, so you should write applications in Rust. That should be nice. Yeah, we have a plugins module now, and they're official and they're upstream, so we might add more plugins in Rust. Stuff on our radar: SDI over IP, CUDA, better OpenCV integration, high dynamic range video. We do that already, but we're missing some signaling, so we can improve on that. And that's all stuff we're going to look at. That's all I have. Thank you very much, and thank you to the organizers. And if you have any questions or comments, I think we might have 2 minutes or something.
We have 5 minutes, so don't hesitate. Yeah.
A question, excellent.
Coming.
Thanks for the talk. Could you help promote getting this version 1.16 into Debian update?
What do I have to do in order to do it? I think we're missing the Debian freeze, but I don't know if anything is required to get it into the updates repository. Sebastian? No? Right. So I think we're going to mix a cutoff in Debian, and then maybe it goes into backports or something, but that's not something we have control over. We're going to release it when it's ready, and it's not ready for the freeze. So it's not going to happen in 3 days. Sorry. If you know people in Debian you can bribe, then maybe we can tweak it. But I don't know what the process is to get it overruled, or if that makes sense or not. Yeah. But usually people who use Debian stable don't really care if they have 1.14 or 16. Any other questions?
So you mentioned the forward reader correction with uneven level of protection, right?
Yes.
Yeah, so I was wondering how far you're willing to go down this rabbit hole, because that IFC is not exactly trivial. And I've seen Chrome does only level 0. I was wondering if you want to do something more complicated about this on your side.
I don't know. It's not really a question of want. It's a question of, if someone really needs it. I mean, the thing is that the ULP FEC spec, it's not very good technically. It's a disaster. It's horrible technically. But I mean, there's a better spec being worked on. Is it Flex Spec or something? Yeah. But I don't think that's stabilized yet. So as soon as that comes out, hopefully. Well, it's used, but I don't know if it's stabilized yet. So I think that's sort of what we should be working towards too, because that's much better on all the specs. It will solve lots of problems. Yeah, that'd be nicer.
So you are working with both RTP and RTSP?
Yeah, I think so. In RTSP, we have it only support in record mode, I think, not in play mode, but it shouldn't be too much work to add if you need that.
Other questions?
No more questions. Excellent. Thank you very much. Enjoy the conference.
Thank you.